Hello everybody, welcome to Blue Marble Science. Mr. Thrive and Survive is having some problems with solar eclipses. I wonder if scale could have something to do with it. You know, we just did a video on the rich method of trying to analyze Earth, Moon, and Sun in 2 dimensions, which is impossible to begin with just because of the tilt of the Earth and the tilt of the orbital plane of the Moon, not to mention the fact that he leaves out significant things like the refraction that happens when you're very low on the horizon. But okay, we got beyond that. Now he's going to try and prove eclipses can't work in 2 dimensions, which you actually can model that way, and he still screws it up. Warning. Again, there is an extreme risk of facial injury and monitor damage. Please push that monitor back out of the way. Get out those oven gloves. And Gladys, are you ready? Let's light this dumpster fire and have more fun.
Hey everyone, Mr. Thrive and Survive. This is going to be a way you can actually prove if this model, prove it yourself if this model is true. You have a huge sun which creates an umbra, and I got all kind of people in this video here, Earth way too big and NASA model, NASA fail, who just tell me that the angles of the sun are this and that, and the Earth is actually, if you reverse it, the moon is actually up here, so it's 4 times larger shadow, blah, 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 blah. It's all based on bull crap. All of it. And you can prove this yourself. Now, why do we have this umbra? Because the sun is so much larger. We have this crisscrossing of light rays, which have to be parallel otherwise. They just have to be.
Okay, numbnuts, where'd you get the cartoon from? Again, this is a not to scale drawing. You can't really look at this and make good sense out of it. Let's look at a 2-scale drawing. Here we go with AutoCAD again. Let me zoom out so that we see the whole thing. Here's the sun way over here on the left-hand side. Here is the moon right here. And this is the shadow being cast during an eclipse. Now in this case, I decided to make the moon appear at its very closest approach to the Earth. That's an apogee of 225,000 miles. At that, you will get an umbra, which will be, let's see if we can measure this very quickly, about 104 miles. In the previous solar eclipse, a year and a half ago, which I was able to experience firsthand, that shadow was about 70 miles wide. That's because the moon's was a bit further away from the Earth. All right. Now let's draw the lines correctly. There we go. Now we have our lines coming from the opposite sides of the sun and casting this much larger penumbra shadow. That's what that looks like. And that's why it works, and that's how it works. How does a lunar eclipse work? Well, it just so happens we have that too. Here's the light coming from the sun past the Earth, and this part in here is the shadow the Earth is casting. And when we get out to the moon on the other side, you can see that the shadow of the Earth is about 3 times the size of the moon. So it works perfectly. All you got to do is do it to scale. Quit playing around with these damn cartoons.
And I've explained that before. If you go for the seasons, look up seasons. How are seasons explained on the Earth? You'll see parallel rays have to be used every time. What is your latitude? Using the sun, you can tell your latitude. Everybody uses that as an Earth proof. Your latitude compared to the North Pole or the equator. You can tell where the sun is, right? Well, that you can only do that if it's parallel rays. If rays are coming in all kind of different angles, you'd never know. Anyway, back to this. How can you prove yourself if the umbra penumbra exists?
At this point, Rich goes on a couple of minute rant berating some of his commenters on a previous video, and I'm just not going to let him get away with that. We'll skip that part.
So one more time. We have a huge sun, much larger than the Earth, so it creates this umbra penumbra much larger than the moon, right? We have crisscrossing. Do the math. 89.9896, something like that, degrees is the virtually parallel rays you'd have to have for 93 million miles. And there's no way light coming off at this angle up here would ever come down and strike the Earth. I'm sorry. But I say give it to them. So how do you create the umbra penumbra? Oh, well, the moon and the Earth aren't as big as the sun, Rich. Well, what if I had a little ball? Would that be as big as the sun? Absolutely not. So let's take a look at a couple examples where you can go out and prove this for yourself if you're not too effing lazy. And I'm sorry to be so pissed at this, but you people are stupid. And you would think after all this time you'd wake up. But no, you got to sit there and Google and come up with all these stupid angles that don't exist. And you can prove they don't exist. Let's take a look. Now here's a little video I took with my phone of a street lamp. Is the street lamp smaller than the sun, do you think? Do you think you can think that through? Is the street lamp smaller than the sun? And remember, according to the planetary astronomer at Arizona State University, the sun is even bigger in our sky than it is in space because the atmosphere diffuses it. So it's even larger than what the sun and moon have to work with. So I'm asking you the logical question. Can you freaking answer it? Is the sun larger than this light? Well, let me go ahead and play this and show you exactly what happens when this light is casting a shadow on the bottom. There should be an umbra penumbra, and it should be smaller. Correct? Well, what do we have here? Uh-oh, the shadow is larger. And what do we have for an umbra penumbra? And this is what you're going to notice with everything. Let me freeze it there. You've got a little bit of a blur on the outside, no more than 1% ever of the blocking object, and it just doesn't keep getting bigger and bigger. And I've tried this from all different distances, all different objects. I've tried it with trees that are casting 200 feet shadows when the sun is low, and this umbra penumbra BS doesn't get any more than a little bit of the edge gets blurry. That's it. And I think I'm being generous with 1%. So this is what you have right there. And the shadow is actually larger than the light post. You can't make it smaller.
You just made a claim that the shadow is larger than the street light, and I can assure you that's not the case. You didn't measure the street light, nor did you measure the shadow. You just assumed that the shadow is larger. It really isn't. I made this little sketch just to demonstrate what you should see, and I think it matches very closely to what you actually did see. I assume the street light up here to be about 18 inches in diameter, and I placed it about 15 feet, 180 inches, about 15 feet off the tarmac. When you do that, and you project the lines of light from the sun, this is what you end up with. The really white part here in the center, the umbra, is about 16.3 inches in diameter. Remember, the light was 18 inches. The penumbra, the outer portion, the fuzzy part, is 19.7 inches in diameter. So this one, the penumbra, is about an inch, 1.7 inches larger in diameter than the actual light is. But the umbra is about 1.7 inches smaller in diameter than the light is. That's reality. That's what you actually see, Rich.
It should be smaller because the sun is much bigger than the light, isn't it? Well, let's actually go outside with a ball, shall we? Can you do this, guys? Can you go outside with a ball and try this yourself? Let's try it. And again, I get so upset because these things are so easy to think through and approve yourself if it's true. And morons keep making videos and everything and making comments that make absolutely no sense whatsoever. They know exactly what the angles of the sun are when nobody else does, and that is a cone, But you can't create this with the exact same sun that the sun and moon use. Here's a ball sitting on there on the surface. So let me go ahead and play this.
No, let's don't play this. Let's play this. This is a channel called I Got Questions. This guy does a great demonstration of what happens to the moon's shadow and why things look the way they look. You see he's got a piece of unistrut there with a tape measure mounted on the top of it. He's got a little globe, and there he's got his simulated moon, and there now you see the shadow of the moon up close. Okay, roughly the same size as the shadow's roughly the same size as the little orange ball. But watch as he pulls this globe further and further away to a point that's ultimately going to simulate the distance the moon is from the earth. And as it gets further and further down, you notice that shadow starting to become smaller and smaller and smaller. Only the really dark part in the center is the umbra. That's where the total eclipse occurs. Look how small the umbra gets by the time it gets way back to the back. The fuzzy part around the outside is the penumbra. That's a really good demonstration. That's what really happens. So how about we stop telling people the shadow can't ever get smaller? There it is, getting smaller, right before your very eyes. He's going to do something else in a second too. He's going to put a piece of paper up with a grid on it that's probably marked off in about 1 centimeter squares. Let's see, I think that's this part right here. There you go. So if you want to pause the video, you can actually measure how many squares the diameter of that shadow is. But now he's going to walk that all the way down to the other end too. And we see the same effect just on a nice white sheet of paper. Makes it a little bit easier to see. But as you can see, the shadow continually gets smaller, contrary to what Rich is trying to tell you. The shadow's getting smaller and smaller and smaller. And the umbra is getting to be really, really small at this point as he gets back here toward the back. Look how small that is. That's the real world. That's what happens in the real world. This is what happens when you do things to scale instead of playing around with basketballs on your back porch.
So I'm going to take the ball and I'm going to pick it up, and let's see if the shadow gets smaller. All right, there's the sun, quite a bit larger than the ball. Same sun the sun and earth move, the earth and moon use during an eclipse, correct? Correct. So let's see what happens when I pick up this ball and see if the shadow gets smaller, if I get this cone effect that is created by the sun, that is so much more huge in this ball. Just imagine the earth and the moon are much larger than this, so I should get all kind of small shadow with this one, right? So here we go. Look at that. The shadow doesn't get smaller than the ball. How is that possible? The sun is so much larger than the ball. And it doesn't matter, guys. I don't care. Do it on an angle when you can go hundreds of feet with this and cast a shadow. The shadow never gets smaller, and you never get more than the very outside edge get a little bit blurry. That's it. You get no cone effect. And you should. It's the exact same sun. It's even bigger because of our atmosphere. So we should get even much smaller shadow. And take two balls. Cast one shadow on the other. See if you can get the shadow to get smaller on the other one. You can't do it.
Well, Rich, I'll leave it up to the viewers to decide whether or not you're being intentionally dishonest or you just actually don't know any better. What I can say is this. Not one thing you said in that video is correct. Every bit of it is bullshit. You need to stop it. You need to understand and admit to reality. I just showed it to you. Hey, thanks for watching. And I hope you enjoyed it. If you did, don't forget to like and subscribe. Don't make me come looking for you. Hey, Gladys. We're out of here.